Now we're going to discuss the conic section called the parabola, which we're already somewhat familiar with this because we've talked about the case of the parabola when it is a function called a quadratic. Parabola that's facing upward looks like this. This is the vertex. And then we have something called the directrix. And the directrix is a line that is a distance from the vertex, a distance of p. From the vertex on the inside, going inside the parabola, a distance of p would give us the focus point. Now the directrix in the focus point helps us determine the graph of the parabola, or the points on the parabola, because if I randomly pick a point on the parabola, and from that point I draw a line to the focus, and I draw a line down to the directrix, this distance and that distance will be the same. Same thing if I draw a point on the other side. If I draw a line from that point to the focus point and then directly down to the directrix, that distance from the point on the parabola to the focus is the same as the distance from the point on the parabola to the directrix. From the focus straight out, straight across the parabola, that line that's straight across is sometimes known as the diameter of the parabola, or it could also be known as what's called the latus rectum. The distance from the focus out in one direction to the parabola is 2p, and from the focus out to the other side is also 2p. So the total distance across the entire diameter is 4p. If the parabola opens up, then the picture will look like this. The focus will be on the inside of the parabola. And this is the case where it is a function or a quadratic because it passes the vertical line test. The equation of a parabola that opens up, if it's in standard form, okay, where h and k is the vertex. So this would be our point HK. Since the vertex is the distance of P from the directrix, and the focus is the distance of P from the vertex, then to find your value of P, you take the coefficient that's in front of the y and divide by 4. Now, when the parabola opens up, your value of P is going to be positive. So all the same information holds true if the quadratic opens down. The only difference is that your P would be negative. You would still have a vertex. Your directrix would be a distance of P outside the parabola and would be a horizontal line. So the equation would be y equals, and then whatever value of y it passes through. And the focus would be a distance of P from the vertex on the inside of the quadratic. Your equation would still be the same. You would have x minus h squared is equal to 4p times y minus k. The only difference in this case, if the parabola opens down, your p would be negative. So you would have a negative coefficient in front of the y. Now, if your parabola opens to the right, then this is no longer a function because it fails the vertical line test. So some parabolas are functions, and that's when they open up or down, and that's when it's considered a quadratic function. If it opens left or right, then it's not a function and it's just considered a parabola. So in the case that it opens right, you would have the vertex is still in the same position. You would still have a focus on the inside of the parabola, a distance of p from the vertex. But your directrix now will be a vertical line and will be x equals and then whatever number that is. And it will be a distance of p from the vertex. Now, your equation, if it opens right or left, would look like this. Where your vertex would be hk, of course. Now, if it opens to the right, your value of p is going to be positive. When it opens to the left, your value of p is going to be negative, but you'll still have the same standard form of the equation. You would still have a vertex, hk. Your directrix will still be a distance of p from the vertex on the outside, and your focus will still be a distance of p on the inside of the parabola. Notice when the parabola opens right or left, it's your y value that's squared, and when it opens up or down, it's your x value that's squared.